times 10 to the 23rd, parentheses. And anybody want to help me out here? 4.6. Okay, so I'm going to write the whole number down first. 4.65116. What's the unit here? The only unit left is moles. Okay, so that's moles of silicon. Okay, back to sig figs. Go back to your initial given. How many sig figs are in our given?
3.
Okay, so 3. Who remembers the rule? Okay, the decimal is present, so we start in the Pacific at the first non-zero digit, so that's 2, 8, and 0. So there are 3 sig figs here, so I need 3 sig figs here. Round this for me to 3 sig figs. 4.65 moles of silicon. And that's our answer. Single step.
Yay.
Canceling units. It's the same thing we were doing with the metric system, except the metric system was like so 5th grade. So we were like, yeah, I feel really comfortable with this. I know how many meters or a kilometer. This is just the new stuff. We're just doing the same thing. It's just understanding how the mole relates to atoms, the moles relates to mass, and the moles relates to volume. It's the same exact process. That's why I kept really emphasizing dimensional analysis is a process. I know you can swoop decimals like just crazy, but that wasn't our process that we needed to use. Okay, next. Write down your given. What am I writing down?
0.32.
0.32 moles of, what's the symbol for potassium? K. All right, so we got moles of K. I'm going to put my little fraction bar, and then you guys are going to tell me on the map where we are. Where are we on the map?
Right there.
Okay, so we're at 1 mole. We're at the mole.
In the map.
And I want to go where?
The map.
So I'm going to go to top, middle, or at bottom?
Middle.
The middle. So I've got to go to mass. And then this clues me into where I get the number that goes here. Where am I going?
Period.
Everybody got your table out on the desk? Okay, verify your partner does. Your partner should have a periodic table out.
Is bigger.
Okay, and back to me. So everybody tell me now, what unit goes on top?
Grams.
Grams, and what unit goes on bottom? Why is mole going on bottom?
There's a mole.
You want to cancel this other mole, right? But what number always goes with the mole when you're converting?
1.
1, and what number goes with grams according to the periodic table?
39.10.
So everybody found potassium, so in group what?
1.
Group 1, 39.0. So write PTOE above that if you want to remember that's where we got that number. It didn't just come out of our butts, right? It's on the periodic table. Okay, what cancels?
Moles.
So moles of potassium, what units remaining? Grams of potassium, and this is going to be like, calculator, 12 and some change, like almost 13? 12.512. Okay, so we calculated, oh, I'm not actually circling this. This is not my final answer. How many sig figs do I have?
2
2 at the beginning, so I need 2 sig figs at the end.
grams.
So round up for me.
Oh,
13 grams of potassium.
bro, let's go.
All right, turn and talk to the person next to you if they have a question.
Do you have a question? Good.
Now's the time to ask the questions. That's not just the simple ones. All right, give me a thumbs up when you're done talking to your partner. All right, a couple of us are still working, but we're going to pause that conversation for a moment. I like to try to make sure you're getting questions either to me or a friend. All right, so for the next one, notice that I have a compound. What's the name of this compound? And before you say it, notice there is no ion, so don't you dare try to name it like a polyatomic ion. It's a compound. Sulfur? Yes. And why do you have to tell me that? Because it's covalent, and you got to tell me prefixes to let me know the subscripts. All right, so it's sulfur trioxide. Okay, so we've got moles of sulfur trioxide, but we're not going to atoms of sulfur trioxide. We're going to atoms of oxygen. So this is like tomato. All this stuff right here is referring to the same, sorry, not tomato. This is apples and oranges. These are 2 different things. So this is all referring to one compound. Like I could go from moles of sulfur trioxide to not atoms, but what particle type? Which of these three?
Molecule.
Why are you saying molecules for sulfur trioxide? Because it's covalent, and that's how you tell me it's bonding type. So I can go from moles to molecules of sulfur trioxide, but I can't go to atoms of oxygen just yet. That's going to be down the road a little bit. Okay, so let's start together, and then I'll kind of whittle down to the details that this requires.
More complicated.
Okay, so 1.14 moles of sulfur trioxide. And, you know, we don't really care about mass, we don't really care about volume, so the logical choice would be the top branch up there. So what is logically going to go on the bottom here?
1 mole.
So we got to cancel moles, so you guys are telling me 1 goes with the mole, beautiful. And you do need to write the identity here, right? SO3, so that you understand we're talking about sulfur trioxide. What goes on top? 6.02 times 10 to the 23rd what? Well, atoms, formula units, are molecules. Molecules. You have to put molecules because this is a covalent compound. Don't say atoms, that's referring to a simple element. Okay, so we haven't even gotten to oxygen yet, but we're making our way there. Okay, so we cancel our mole of SO3, cancel our mole of SO3. Now we're in molecules. Let's say you had to draw a molecule of SO3. You'd go back to like Lewis dot structures, right? Okay, SO3. So how would you draw that? I know you count your valence electrons first, but I'll let you skip that step. You put S in the middle and
3
3 oxygens.
And then 1
That's what actually we don't hold on. That's because I counted my electrons. You jokers didn't. Okay, so there's sulfur trioxide. Done. If you look at this 1 molecule of sulfur trioxide, how many atoms of oxygen are inside of it?
3.
3. You just counted them. 1, 2, 3. So in one honking molecule, you can count the insides, which are made up of atoms, and that can give you a new relationship. Now that new relationship is not on your map yet, right? Because we just made that up. Not often can you make things up, but today, in this instance, yes, you can. So the idea is that within the representative particles, there's molecules, but inside the molecules, we have atoms. So occasionally, and then maybe denote this on your map, star. Sometimes you have to make a ratio from atoms to molecules or molecules to atoms. And that's made up, but not just like pulling out of your butt made up. It's you drew the molecule and you counted the atoms. Or instead of drawing it and wasting my time, what could I also do?
Just look at the subscript.
Just look at the subscript. It's telling you right there, I have 3 atoms of oxygen in 1 molecule of SO3. Before I write this on the board, here's my other example, which might make more sense. I go to the store. I'm not going to check out. I'm like, oh, I really need some Reese's. Okay, need them. What do I pick up? A pack of Reese's, right? So I have 1 pack of the candy, but inside there's 2. So I'm getting 2 atoms of Reese's for 1 molecule of a Reese's package. That's what this is. Does that make sense?
Yes.
All right, talk to the person next to you, make sense together if you haven't yet.
Makes sense.
Give them a pat on the back. They got it.
Your explanation. Okay. So there's something big, and then there's something little in between.
Got it.
Pretty much.
Perfect. Okay, come back to me. Come back to me. Some of your explanations are spot on. Okay. So what unit do I put on the bottom?
Molecules. Atoms.
Hunter, can you tell me what unit I have to put on the bottom? Okay, I'm going to put 1 molecule. In 1 molecule of SO3, I have how many atoms though?
3.
3, because you guys can count, and you just did. And we got 3 atoms of O. So this is a ratio which I have made up educatedly, of course, because I drew my structure. So molecules cancels, boom. Atoms of oxygen, done, because that's what the question asked for. Calculate.
All the numbers. The top one multiplying the bottom. So it's a big number. Number.
right, does it start with a 2?
Yeah.
Okay. 2.05
Oh, 5,
8
8
times
4.
10 to the 24th units. Atoms of O. Okay. Oops, I don't need to keep circling this. This is not my final. How many sig figs do I need? 3 sig figs. So round this to 3 sig figs.
2.06.
That's it? Thank you. Times 10 to the 24th atoms of O. That's the for real final answer. Okay. All right, so that was a little harder because we had to like think inside and pull out the atoms as an individual. All right, I want you guys to do the next one with the person next to you. Go.
4.5. So it'd be these two things right here. How about you do it and I do it? Let's see, okay. Let's see who has better vision. Better or
This bigger?
Oh, money. Mold. Okay. For sure. And then I gotta get rams.
1.5
The first.
of sodium phosphate.
You guys need to write your formula down. I don't see formulas.
Sodium this thing. Where's the phosphate? PO4. Oh, I can I thought this was got that far. Oh, never mind. It's more simpler than I thought.
All right, back to me. 5, 4, 3, 2, 1. Back to me. All right, so I know some of you guys are already done, and I went around, I tried to check formulas. Give me a thumbs up if you got the formula right finally now. Okay, Na3PO4, some of you guys had it right before me, so I appreciate you knowing your phosphate. You know you have to cancel moles, right? And so over here, the mole and the mass is only connected by one branch, and that's the PTOE. So you're looking at the periodic table, and you have sodiums, 1 phosphorus, and 4 oxygen. So how many sodiums do you have?
3.
So in your calculator, to get the molar mass, you're putting 3 times what?
23.
Is it 22.99?
Yeah.
All right. Is it 23 on some of you guys? Okay, so you go 22.9. You need to be exact, okay? Plus 30.97. Is that phosphorus? 30.97? Yes. Okay. Plus 4 times 16, meaning the molar mass of oxygen. So 4 times 16. Total that up. What do you get?
163.91.
163.94.
I got 9 more.
All right. So note to self. Shh.
Because it's PO.
You need to put the sum of the periodic table right here to represent the grams that that compound is made up of. So you can imagine, if you don't know the formula, you're going to get the molar mass wrong, right? Which means you get the problem wrong. So the formulas are coming into play, and they're whipping our butts. All right, so mole cancels, grams remains, grams of Na3PO4 total are that number times our molar mass, and what do you guys get? 0.741, and that's to get sig fig, so there we go. 0.741 grams of sodium phosphate. Okay, start the next one, and then I'll jump in about a minute. Start the next one.
What is alcohol?
Oh yeah. I was looking for the periodic table paper sheets.
So 22.4 equals 1 mole. So this is the coverage.
All right, eyes up. 3, 2, 1, eyes up. Give me a thumbs up if you made it this far. All right, so you knew you had to cancel liters, so you went ahead and put the 22.4 liters on the bottom, you got to 1 mole. Matt, can you tell me what y'all's next step was? Oh, okay. Can you tell me the next? No, cancel the liter. So how did you cancel out mole? What was your next step? Or maybe your next thought. It's okay, it's wrong. Okay, so why do we get a molecules of CO2? Because CO2 is a covalent compound. Good. So we should go to now particle type, which is molecule. So in terms of canceling out moles, what do I put on the bottom? 1 mole of CO2, and you need to label this so you know you're not in atoms of oxygen yet. So 1 mole of CO2 will cancel with 1 mole of CO2, but you guys said to go to molecules, so it goes on top.
Molecule.
Number.
The 6.02
Times 10 to the 23rd molecules of CO2. Okay. Now, we whittled it down to just a little molecule. And if you have to draw it out, it'd be like this. So we've got a little molecule here, right? So inside of that Reese cup package, inside of that molecule, what do we have? That's important.
2 little peanut butter things.
2 little peanut butter cups, or 2 oxygen atoms. This is that final step again, ratio atoms to molecules. If you've not written this down yet, put a star by it. That's the only thing that's not so intuitive. You have to like kind of think about it as you go. So then what am I putting on bottom? In 1 molecule, so our 1 Reese cup package, you have 2 little atoms of oxygen. So this is that weird step that we have to make up a ratio, but it helps if you know the formula. And then calculadora, por favor. Say again?
1.3 times 10.
Well, it was 1.2 something though, right? Before rounding?
I got 1.34.
Oh, 1.3. Okay, 1.343 times 10 to the 25th atoms of oxygen. And just as a quick review, how many sig figs are in our number up here? 2, so 2.5 is 2. And then I need to round this to how many?
1.3.
So 2 sig figs would be 1.3. I like to repeat that. It's the teacher in me. All right, last one. You guys do the last one. You guys are like doing fantastic, by the way. I'm not sure if everybody is, but I'm trying to make sure we all are.
Formula units, right? Yes. Lead, iron.
A formula units. Lead is pretty good. A lead up.
LE, lead. Lead. Where's lead Henry? I thought it started with a P. PP. Iodine. What's iodine? Iodine.
I know, but like,
Because it's formula unit. Formula unit means ionic. This is when go to the census third the formula is PB2. I'm pretty sure I have to. I'll be going FT. No, PP. What is what is PB? PB. What is PB on this? There it is. 207.2.
This is a weird calculation. Yeah, it's
yeah, it's cute.
All right, come back to me. 3,
Calculating 6,
2, 1. Back to me. I was going to try to write with it. It wasn't worth it. Okay, so 1.91 times 10 to the 21st formula units. Well, that's just a ionic particle type. Okay. So, what's lead to iodide? PBI2. We need the formula because eventually we're getting a mass, and if our formula's not right, we might as well just flip the table because we're done, right? So, you have lead to iodide. You've got formula units. So, and I was just showing someone else this. This is a road. Your finger cannot be picked up. You are a car. Touch particles.
Boom.
Particles, follow the yellow brick road through all the way to mass, but you can't go from here to here because there's no road here. So go from particles to moles to mass. So it's a two-step process. Two-step process. Back to me. Particles go top or bottom here. Particle to cancel them. Make a choice. I need to cancel formula units. Bottom. Okay, so third time's charm. Here's 6.02 times 10 to the 23rd formula units of lead to iodide in 1 mole. Remember, always 1 for mole. Okay, we have made it to mole. Now, formula units have canceled. Okay, now, like next. Cancel mole. Well, how do I cancel mole? So I put 1 mole in bottom of lead to iodide. Hold on. Let's just double check we're all clear before you tell me the next step. I know we're going to mass. Well, mass is in grams, so we'll put our G for grams and lead to iodide. Everybody point to lead on the periodic table. 207.2, okay, plus 2 times iodine, so that's 2 times 126.9. 04. Okay. So together, don't say yeah, hold on. 461 point something. Oh, 00? Okay. Close. Okay, so then your mole cancels with lead, or lead to iodide, and the only unit left is gram. So the final answer will be grams of lead to iodide, but how many grams? Okay, can we verify the person next to you before I heard some different answers? 460. I'm asking for the answer. I'm asking for the answer. I was like, I got that number already. 1.46.
26. 1.46. We can just say your answer. Your answer's probably right.
Thumbs up if you made it in the calculator this far. Do not, and this is just a caveat. Let's just not pretend that, oh, I got a calculator. I can use the calculator. The calculator is tricky, especially if you have to put parentheses in the denominator. So when you put parentheses divided by parentheses, that's going to give you your successful answer, and then of course we multiply by 461. Don't get cocky and then don't try it on the calculator because you're like, I got this, because then you'll screw up on the test because you didn't practice with parentheses. So practice makes perfect. Okay, so give me a 1 out of 10. How do you feel? 1 is I'm going to dig my grave now, and 10 is I'm flying high. I'm good. All right, I just want to know where we are. All right, hands down, hands down. All right, so as a way to make sure I get everybody on par, I need to work with a couple of individuals, but you guys have homework, which is 1 through 8. Look at the next part of the worksheet you guys have been looking at already. Those of you who have not pulled theirs out yet, it looks like this. And I want you, let's take a couple minutes and start on 1 through 8, okay? So if you need to work with someone else because you feel like you can get information from them, do that now. Start 1 through 8. Raise your hand when you need me. 1 through 8. On the sheet I gave you yesterday. I really don't want to have to be Rihanna. Work, let's go, okay? Wow. I know it's a little old, but it still works. Yeah. 1 through 8, and then step up. What if I was in the way? I need a place to work.